this is the last day of concavity in section 3.4. I'm going to be honest with you, this problem we're about to do is going to take some time to complete. I probably will not finish within the first video, so understand that it will probably be a continuation of a video. What we're going to have to do is we're going to have to find A, B, and C, and D such that the following conditions are met. So what we're going to be doing is using a lot of algebra and just some knowledge of our calculus to be able to figure this out. The first thing I'm going to do is I'm actually going to use these 2 points to create two functions. And what I'm going to do is I'm going to place 2 in for x and 4 in for y. So I'm going to have 4, that's my y value, is equal to, okay, remember that's the y value, and I'm going to place 2 in for all of these. So I'm going to have 2 cubed, okay, and 2 cubed is 8, so I have an 8a, plus I'm going to put 2 in here, and so I'd have 4b, plus 2c, plus d. There was no x to plug in. I'm going to do the same thing for 4, 2. So I'm going to plug 2 in for my y, and then I'm going to plug 4 in for each of my x values. Well, 4 cubed is 64a, plus 4 squared is 16b, plus 4x, or no, it'd be 4c, sorry, I'm putting 4 in for x, plus d. Now, what that does is it creates 2 equations with 4 unknowns, so it's going to be quite difficult to solve. What I could do, though, is I can eliminate one of those variables just by simply changing all these to negatives. Now I'm able to add those together, and I'm going to keep changing colors so you guys can see the difference. This would eliminate the d's. I would have 2c plus 12b plus, this would be 36, or not 36, but 56a equals negative 2. Now, in order to come up with another 3-variable function, what we're going to do is use some of this other information that's there. So, one of the pieces of information that I could use is about the first derivative, and that would include some of this information about relative max or mins. So what I'm going to do is I'm going to actually find the first derivative. And I'm going to find the first derivative of the original function right here. So the first derivative would be 3a x squared plus 2bx plus c. Well, what does that do for me? Well, because this is a relative max, I can actually say that my first derivative, or that f prime of 2, at 2, I would have 2 squared, which would be 4. Okay, so I'd have 4 times 3, which is 12a, plus I'm plugging 2 in for x, I'd have 4b plus c. Well, what does this actually equal? Because I know that it is a max, and that maxes have the derivative equal to 0, I now have an equation of 3 variables. And what I'm going to be able to do is match that up with this other one and solve both simultaneously. To make this a little bit simpler, I don't want these huge numbers. I'm going to go ahead and change this to be negative 1 equals, so I'm going to divide all this by 2. So I'm dividing this by 2. That would be 28a plus 6b plus c. And I'm going to go ahead and put these 2 together. So I'm going to move this one up here, and I'm changing colors on you here. So I've got 12a plus 4b plus c. And I'll get ready to solve those simultaneously. I should be able to fit that in here in this video. So I'm going to change all of these to be negative. That way I can add them together. This gives me 2b plus, that would be 16a equals negative 1.